What's going on, everybody? Mr. Diamond, and I have, in fact, found my calculator. So I'll actually be able to work out these problems with you. We're going to be working out the elastic collision example. I didn't write down the actual phrasing of the question because we've got a picture, and a picture is apparently worth approximately 1,000 words, or I guess you could call that 1 kiloword. So we have what I'm going to call object A, or ball A, weighs 0.440 kilograms and is moving at 3.80 meters per second to the east. So we're going to make that to the right. Just for reference, we're going to make to the right positive. And it's going to hit ball B, which is a mass of 0.220 kilograms. And then after that happens, we want to know what is the VA at position 2 and what is the VB at position 2. I'm going to know what is the velocities of each of the balls. Now, you'll notice that so we have our ball moving forward. It's going to hit into this one right here. We know for sure, at least I assume most of you are feeling pretty confident that, okay, so ball B is going to go forward, like afterwards. Now, I haven't drawn this to scale, so that may change what your answer would be to this first question, though, which is, or this other question, which is, if this is going to go forward, which way is this going to be moving? You can kind of think of situations where it could go either direction. Like if you throw a ball at a wall, it's going to bounce back. But you could also, like, you know, like it could be hitting the ball and just continue forward, like add a lot of energy to the ball as it's moving forward, and it's just going to continue going forward slower. So I don't want to make an assumption that you're going to, you will know right away whether or not it's moving to the left or to the right. And honestly, it doesn't matter. When we solve the problem, it'll tell us. If our VA2 is positive or if it's negative, that's going to tell us what direction our ball A is moving. So I do want you to go ahead and make a guess before we start. Do you think that ball A, after it hits ball B, is going to continue moving forward, or do you think it's going to be bounced back by the ball? So make a guess for that. If this was a YouTube video, I'd say leave that in the comments down below to increase engagement. But this is not a YouTube video, so we're not going to do that. So let's look at the information that we have. So we have M of ball A, and we have VA at position 1. We have M of B, and we have V of B at position 1. So mass of B, 0.220 kg, and velocity is 0 meters per second. Our mass at position 1, 0.440, and our mass is, or our velocity is 3.80 meters per second. Then over here to our other side, VA2 we don't know, VB2 we don't know. You also might be thinking, I guess I didn't even consider it as an option, but it is an option that could happen. Maybe ball A stopped. Maybe it hit it and it just continued forward with all of its momentum. I guess you could also just say, like, I guess having the question marks there is good enough, but we genuinely don't know. It might be 0, it might move forward, it might move backwards, but the problem will tell us. When we solve it, we will actually figure out what it's supposed to be. We do still have our same mass A, I guess I should use lowercase ma is 0.440 still, and mass of B is 0.220 still. Now, we know, because it is an elastic collision, we know that the kinetic energy at point 1 must be equal to the kinetic energy at point 2. We know the momentum total, I guess it's supposed to be lowercase, P1 is equal to P2. And because of that information, because we know that information, we can use our simplified, or our kind of shortcut equation. We know that VA1 plus VA2 equals VB1 plus VB2. We have this set of equations, and we get to pick and choose which ones we're going to want to work with. You can work with kinetic energy. If the problem asks about kinetic energy, you obviously want to use that one, but this one does not ask about kinetic energy, so we don't really have to use it at this point. So what I'm going to do is I'm going to set up my my velocity equation, and I'm going to set up my momentum equation, and we're just going to see what we have and see what we're missing. So first, I'm going to do my P1 equals P2. So at stage 1, I have MA times VA1 plus MB times VB1, but our velocity at B1 is 0, so that's going to get canceled out. That's going to go to 0. Then that's going to be equal to MA VA2 plus MB VB2. And these, one of these might be 0, like this velocity might be 0 right here. We don't know yet, so we can't make any assumptions. We'll have a method of solving for that in a little bit, though. Okay, so for the second piece of information, we have our VA1 plus VA2 equals VB1 plus VB2. That's our second equation we're going to have. I don't need to like write that out or expand it out in any way. So let's see what we've got here. We have MA1, so that's 0.440. VA1 is 3.80. That's going to be equal to MA 0.440 times VA2. We don't know what that is. And then plus, we know our mass is 0.220, and we know it's going to be VB2. So we have two unknown variables in that one. And if we check, we can actually pull down, based on our other equation, VA1 plus VA2 equals VB1 plus VB2. We can plug in our information there as well. So we know that 3.80 plus 0 is going to equal VB1, sorry, plus VA2 is going to be equal to 0 plus VB2. Almost had my equation wrong. I apologize. I actually screwed that up like a whole bunch last year, and it led to me making a whole lot of mistakes on the worksheets and the test. But this year I'm going to make sure I don't do it, have it written down correctly on my little cheat sheet. Okay, so we have VA1, which is 3.80 meters per second, VA2, which we don't know, VB1, which was 0, VB2, which we don't know. And what we now have is a system of equations. We can ignore this 0. It's not going to affect our outcome. So we know that VB2 is equal to 3.80 plus VA2. So we can take our, let me use a different color since I've got one close. We can take this VB2, we can solve for or use this side of the equation here, and we're going to plug in this in place of our VB2. And that's going to let us solve what is the velocity that our object B, or our ball B in this case, has after it has been hit. So now I'm going to have to rewrite this equation. I'm going to go ahead and solve for some of the pieces, though, to make writing it down a little bit more simplified. So I have 0.44 times 3.8. Let me scooch the camera down a bit. There we go. 0.44 times 3.8. So that gives us 1.672. So that's going to be this piece, equals 0.440 VA2 plus, and then we're going to get 0.220 parentheses 3.80 plus VA2. So you can see we've solved VB2 over here is by itself, so we're going to plug in 3.80 plus VA2 into our VB2 unit over here. We're solving a systems of equations problem by doing that. So now we're going to have to distribute. So we're going to have 1.672 equals 0.440 VA2. So now we're going to have plus, I'm going to do 0.220 times 3.8. I get 0.836, and then plus 0.220 VA2. All right, so once we have done that, we now just have to solve for VA2. So to do that, I'm going to subtract this to the other side. I'll get 1.672 minus 0.836. And then divide that by, these are going to combine our like terms. We have 0.440 VA2, 0.220 VA2. That's going to be 0.0660 equals VA2. Because this would have been over here, we're going to divide it to the other side. So we can plug that into our equation. 1.672 minus 0.836 equals 0.836. Well, that's interesting. And divide by 0.660, we get a speed for VA2 of 1.26666, repeating, which we will round to 1.27 meters per second. Now, the tricky part about these questions is don't get caught up in that, oh, I've solved it, I figured it out, now I'm done. Because no, you are not finished. We figured out what VA2 is going to be equal to. So we now know one of our components. VA2, I'll write it over here, VA2 equals 1.27 meters per second. We want to know what both components are. We were asked to solve for both of these pieces of information. So what's the speed of both of them? So we now know that ball A is actually going to continue moving forward. It's just going to be continuing to move forward kind of slowly. We can now plug this back into our already solved problem here and solve for what our VB2 must be. Or, as it's actually going to be a lot easier, we could also plug it into our V equation down here, our velocity equation. It's going to be a lot easier to do it that way. So VA1, we had 3.80 plus VA2, we now know is 1.27 equals 0 plus whatever VB2 is. VB2 is just going to be equal to 3.80 plus 1.27, which as I'm typing in, I realize I could have done it in my head, 5.07 meters per second. So they're both going to be moving forward, but ball B is going to be moving forward at a much higher speed. And if we kind of think about what's happening here, it's not as easy to just look at and go, oh yeah, that makes sense. Like in the example where we were dealing with, like if you have a ball bouncing off of a wall, if it imparts its velocity into the wall and then the ball doesn't budge, it's going to then bounce immediately straight back at the same speed that you launched at the wall. If you have a, for example, like the train car where we doubled the mass and it cut the speed in half, that was like a lot easier to go, oh yeah, like I understand that. I get where all those numbers and that information is coming from. This one's a little bit tougher because there's not like a clear, like, yes, this was half the weight, but it didn't really half the speed. A good way to kind of know that you're on the right track, though, this number is like less than half, and this number is a little bit more than double, or is like getting to the double range. It's going a kind of close. Actually, it's not even that close, but it's definitely going faster. This one was reduced. This one what a pretty reasonable speed. It is less than double because I guess it would be going double if it would have imparted all of its velocity into it. But like I said, this is kind of one that's harder to like actually look at and go, okay, like I 100% get where this makes sense, like where all this information is coming from. But we can kind of at least guess that, well, VA2 is lower than it was to start. VB2 is going fast, but it was also smaller. So that kind of logically makes sense. All right, that's what I've got for this video. If you've got any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a good rest of your day, everybody.